Let's just wait for the others to join before we start, you know? Good afternoon, everyone. Am I audible?
Yes po, sir.
So, may concern lang ako regarding dun sa mga nagka-conflict. Kasi, ang alam ko, sa registrar, kapag ganyan, kapag nakikita nila with conflict schedule, dinidelete nila yung subject. Baka kasi mamaya, akala nyo enrolled kayo, tapos ay hindi na pala. Ano bang sabi sa inyo dun sa inyong basic Alex? Sino dito yung mga ano?
Sir, regarding po dun sa kanina ko pong message po is okay na po. Makikisitin daw po kami sa O8. Same schedule.
Same schedule ng
Yung Thursday po at saka Tuesday po natin ay katulad po ng nasa portal. Kami po ay makikisitin po sa O8 ng aming basic electronics po.
anong schedule noon?
5 to 7 po ng Tuesday po, sir, yung aming sisitinan po.
5 to 7 ng Tuesday. 2 hours lang? 2 hours lang.
Opo, opo, yun sa basic po namin, 2 hours po yun.
Sadyang 2 hours lang yon. Two hours lang talaga siya, hindi siya ano.
Hindi po, ang bali po yung Thursday po namin is nailipat po ng Tuesday. Bali yung Friday po namin schedule ng basic is yun pa din po. Bali po 2 days pa rin po kaming magtitake ng basic electronics.
Pero yung original section nyo ng LX, coincide pa din sa schedule natin ng 5 to 8 ng Thursday? Or nag-iba na kayo ng section?
Hindi po napagtan, sir. Bali, makikisitin na lang po kami sa time po ng Tuesday po. Bali, yung
Ay,
schedule po namin ng Thursday, pumayag po si sir. Gawa ng same prof naman po.
ay yun nga yung concern kasi. So, ibig sabihin, sa portal nyo, conflict pa rin ang schedule ko at ng basic LX. Tama?
Yes po.
Opo, sir.
Ay, yun nga ang problema. Kasi, hindi ko din sure ha, pero ang alam ko, pagka may conflict yan sa registrar, either pinapadrop nila yung isang subject kahit pa may internal arrangement kayo ng faculty. Hindi ba pwedeng lumipat kayo mismo ng schedule ng LX na mag-fit sa inyo? Ito naman ano lang, kasi baka mamaya, pag gano'n na mangyari, Eh, hindi ko alam. Baka mamaya biglang ma-delete na lang sa portal nyo ang subject, hindi nyo pa alam. Baka maging concern yan. Halimbawa, attend kayo ng klase, tapos later on, pag magbibigay na ng grades, hindi naman pala kayo enrolled. Eh, paano yun? Ayun, yun naman yung ay concern ko lang na ano. So yun, ano nyo muna, kumbaga, i-clarify nyo muna yun. Although wala naman problema sa akin kasi kayo naman nga yung naka-enroll. If ever na pwede naman yung gayon, edi it's up to you. Kasi yung subject naman natin, open naman yan. Since naka-enroll naman kayo dito, hindi kayo ang bahala kung ano yung kung attend kayo or hindi. Ano? Yan. Tapos, meron ba kayong ibang klase every Tuesday ng ano, yung 8 to 10 natin? I mean, yung mga kasunod na subjects during Tuesday ng 8 to 10.
Ako po ay meron, sir. Meron po siguro yung iba. Magkakaibang section din po pinanggalingan po ng iba.
Meron. Pero, alimbawa, katulad nun, di ba kapag Adweeks tayo ay ano, yung face-to-face nung laboratory, tapos yung lecture natin supposedly is online. Is it possible na tayo ay mag face-to-face din ng Adweeks ng Tuesday ng 8 to 10? Kasi may
Pwede naman po
available
siguro yan, sir.
oo, kasi may available room dito sa amin. So I will
Opo, sir.
be
Pwede po.
reserving the room para dun sa klase natin para at least mamimit ko kayo nung kalahati man lang nung supposed to be ay face to face. 'Di ba? Since every other week tayo magmi-meet, at least man lang yung even odd weeks mamimit ko kayo ng face to face. Kasi ang hirap din mag-discuss ng ano lang, ng 3 hours lang na face to face. At least kung may Tuesday tayo na Adweeks din, hindi 5 hours tayo makakapag-meet ng face to face. Ano?
Pero sir, proceed pa rin po tayo sa Thursday po na Advic po ay face-to-face.
Mm. Same
Pero
yung
lagi po kayang 8 po kaya lagi ang labas po natin. Gawa may nag-raise lang po sa akin ng concern kung paano daw po yung pag-uwi pa po ng mga ganun. So,
wait lang ha, check natin. Kung Thursday, ano? Check natin. Wala kasi tayong available na rin. Ay, wait pala. Parang mali pala yung natingnan ko. Hindi pala siya available yung Tuesday. Kasi mahirap nito ay kayo iba't iba ng ano. Even weeks pala yung available yung room ng Tuesday. So, hindi rin pala possible.
Sir, may tanong lang po ako.
Yes.
Bali po doon po sa conflict po namin, saan po namin nire-raise yung sa schedule po namin?
Kasi pag sa registrar niyo na ni-raise, baka kasi ipa-drop or ipaghanapin kayo ng section kung saan mag-fit ng schedule nyo. Ang concern naman doon, kung makahanap naman kayo ng schedule na mag-fit sa inyo, papayagan ba kayo ng department na lumipat doon sa kabilang section? Yun naman ang ano doon. Kasi baka mamaya pag naglipat-lipat kayo ng section, maubos naman yung laman ng inyong original na section. Ilan ba kayong ganun ang case?
17 po.
Yun. 17 kayo na ganun ang case. So, hindi kayo makakalipat ng ano ng ibang section ng either LX or dito sa subject ko. Walang possible na pwede paglipatan.
Regarding po sa mga lipat-lipat po ng section po ay ang alam ko po ay mga puno na po ata ang slot. Siguro po ay papalapitin na lang po namin sila po sa program chair po o kaya po sa ay ma'am, sa program chair na lang po kung pwede po kung pwede po 'yon at kung hindi po sila ma-enroll para po ma-check din po. I-raise ko na lang din
Yun.
po sa governor po namin.
Ano pong mga time slot ng available nyo ng Tuesday?
Maghapon po kami ng Tuesday, sir.
Anong oras particular?
Hanggang 4 po.
Hanggang 4. Kasi if ever sana para may room tayo, pwede ko siyang ilipat ng 4 to 6 ng Tuesday. Para ma-meet ko kayo ng face to face. Kung amenable sa lahat. Meron bang magko-conflict if
Sir,
ilipat
kami
natin?
po. May klase po kami ng
Meron
2 to
po
5
sa
ng machine design po.
2 to
meron po
5.
sa amin hanggang 5 po. Opo.
Okay, sige. Wala naman problema doon. 12 to 2, meron. Pag Tuesday na.
May klase din po.
Klase po.
Sa ibang araw, aside from Thursday,
Friday
meron
po
ba
at
kayong
Saturday, sir. Yan po ang luwag ng schedule.
common to all yun?
Hindi po sa lahat. Siguro po yung Saturday po yung ano. Pero yung
Wala
Friday
kang
po meron
pumapasok
po
ng
rin.
Saturday.
Maghapon din.
Ang Friday kasi available is 1 to 4. So kung hindi, sige, mag-stick na lang tayo dun sa sa Tuesday. Yun nga lang, di. Pag even weeks, online kayo dun sa iba nyong subject na kasabay.
Opo, lahat po. Online po.
Ano yun? Malapit ba yung pagitan nung nung subject ko dun sa iba nyong subject?
Yung iba po, opo, parang 30 minutes po.
30 minutes lang. Sa bagay, 1.5 hours nga pala ang inyong setup. Ay siya, sige. Kung yun ibig sabihin kung ganun magiging setup natin, siguro mga 30 minutes before time, pwede tayong mag-dismiss ng klase. Pero 1 hour, kasi nasa time ko pa kayo uuwi kayo nun. Kung may mangyari sa inyo, edi nasa time ko pa. Sige. Tingnan din natin, Pero for the meantime, edi muna. Stick muna tayo dun sa schedule. Siguro yung i-clarify nyo na lang muna is yung concern ng 17 na merong conflict. Kasi baka mamaya nga yung sinabi ko sa inyong senaryo, pag nakita siya ng registrar, nakita may conflict, baka mamaya is i-delete sa system. Yun na lang muna ang inyong i-resolve. Then, stick muna tayo dun sa ating schedule. Okay?
Sir, may isa pa po. Yung isa pa po ang concern, yun pong chinat ko po sa inyong na double entry po. Dahil kung advice daw po sa kanya is i-unenroll. Tapos nung mag-enroll na po, wala daw po yung slot niya sa section na to.
Hindi na ba siya pwede magpaano? Ay, hindi kaya dahil conflict na siya? Kaya hindi na lumabas yung kanyang slot? Possible kasi yun. Tingin nyo. Or kung possible naman, di ba pwede magpa-add ng slot?
Siguro po ay, sir, naging conflict nga po ata dun sa LX nila nung na-move nga po yung
Ayun.
nagkaroon po siguro ng conflict po doon kaya po hindi na madulo. Pero may slot pa po siguro yan.
Kasi, wait lang. Check ko din. Pag tinignan natin siya sa class scheduling, wala na yata na internet. Wait lang. Check lang natin yung... Hindi. Wala na talaga siyang slot. 40 out of 40 net. Anong pangalan nung ano? Nung nawala ng slot?
Catherine Mendoza po, sir.
Oo nga. Dalawa na lang yung Mendoza dito eh. Pero, nawala na yung mga double entries. Oo nga. Nawala na din yung mga double entry dito ngayon. So, kung di naman siya conflict, paano man pwede kayo magpa-add ng slot? Di sabihin na lang sa program chair. Baka makaka-request. Okay lang naman sa akin kung magdagdag ng isa. Isabihin nyo na lang. Okay, pag-usap na lang kayo sa program chair. Ano?
Sige po,
Ano
sir.
na lang
Thank
muna ang gawing Sige. E di, for the meantime, hindi ganun muna ang gagawin natin. Kung talagang hindi pa naman tawag ito. Hindi pa totally ayos naman ang hangga't hindi nagko-close yung enrollment. Ano? So, for the meantime, hindi ganyan muna yung setup, pero mas maganda pa rin na ma-verify nyo sa registrar or kung sa department nyo kung ano yung magandang gawin. Kasi baka nga mamaya is attend kayo ng klase tapos wala naman pala kayong magiging grade at the end kasi nga may conflict yung inyong schedule. Ano? So, wait lang. Intro 2. Sige. Set up ko lang po aking Okay, so for the first part of our lecture, so we will be dealing more muna on reading comprehensions muna tayo ngayon. And then later on, we will go to the problem solving. And so of course, sabi nga, since this is your second take na on the subject, pagpasensyaan niyo ang boses ko ha, at ako yung medyo talagang singab na singab ngayon, hindi ko alam kung bakit. Pero, ayun. Pinipilit ko lang magsalita at talagang baka mamaya wala na akong boses. So, bear with me na lang kung medyo hindi naintindihan, hindi sabihan nyo na ako. So, for chapter 1, I will be siguro posting this. Naggawa ba kayo ng GC? Sa Messenger? Or,
Meron po, sir. May GC po.
so, paki-add na lang ako. ang profile pic ko dun sa ano ay yung nakatayo ako sa parang ano ba yun, art or something. Or nag-request na ba kayo? Hindi naman. Parang wala pa ako natatanggap na request.
Nag-friend request po ako, sir.
Pero dun sa ano, ano, sa mismong group chat, di mo pa ako in-add.
Hindi pa po, sir. Hindi ko po kasi ma-add gawa po hindi po na-accept ka.
Ah, okay. Cool. Wala bang invite link yun? So, pwede mag-join. At YouTube. Facebook. Wait lang. Check lang na. Or kung may GC na kayo, siguro sa'yo ko na lang send via email. Tapos ano na lang. Distribute na lang sa mga klase mo.
Sige po, sir.
Upload na lang ako ng file. Para at least may copy din kayo ng lecture. Ano lang mag-upload pa to. Okay, so let's start with the discussion proper. So, our first lesson for our course, DC and AC machinery, will be all about introduction to energy conversion. So, of course, before we proceed to the um, discussion proper on how motors, generators, and transformers um, produce power or energy or utilizes energy, so we have to first be familiar on how this or how they work. So ano ba yung mga principle wherein um, it is responsible for the energy conversion na tinatawag natin. Kasi syempre, di ba, energy can be of many different forms. So, for our introduction, so energy is a fundamental need of our everyday life. So much so that the quality of life and even its sustenance is dependent on the availability of energy. Hence, it's imperative for us to have the conceptual understanding of the various sources of energy, the conversion of energy from one form to another, and the implications of this conversion. Kasi hindi naman porke nako-convert yung energy into one form to another, basta ka na lang din makapag-convert. Or hindi naman kasi possible for us to convert um, energy ng basta-basta from one form to another. And you must have heard that energy conversion from one form to another is a well-known phenomenon. And the law of conservation of energy even tells us that the only thing that takes place with energy is the transformation from one form to another. This means that we can convert electrical energy into heat energy and light energy, solar energy to be converted to chemical energy, potential energy can be converted into kinetic energy, gravitational potential energy can be converted to kinetic energy, and etc. So, surrounding us are different energy transformation na possible na pwede mangyari. So, even with a simple appliance, yan, that is already applying energy conversion. So, from electric fan, yan, yung mga, blender, yan. So, those utilizes the conversion of energy. Even light, yan. Yung mga ilaw natin, light or electrical energy can be converted into light energy, then it will then be converted to heat energy. Kasi ang end product mostly ng energy conversion ay heat. So energy conversion can be defined as the process where there is a change in energy from one form to another, such as the conversion of nuclear energy into heat energy, or the conversion of light energy into heat, thermal energy into work, or etc. So yan. Um, diba? Sabi natin, energy can neither be created nor destroyed, but it can be transformed from one form to another. So meaning whatever energy we convert, kung ano yung input energy natin, that should also be the output energy. So that is an ideal setup. An ideal setup yon. Yung ang input mo should always be equal to the output. Yan. But, o yung tinatawag nating perfect na system. But then, sabi nga natin, wala naman tayong perfect or ideal na system. So, there will always be what we call the losses. Meron tayong mga losses dyan. So, ibig sabihin, yung input natin, mababawasan na yan as it go on with the process of conversion. Meaning, yung output mo will not be equal to the out. Yung input will not be equal to the output. Okay? So for our intended learning outcomes at the end of this module, it is expected that you will be able to, number one is to identify the different principles and concepts of energy conversion, magnetic and electromagnetic induction. Number two, relate the effects of electricity to magnetism and how it is being produced. Number three is to define the different magnetic and electromagnetic parameters. And number four is to solve problems related to magnetic and electromagnetism. Now, so let's proceed to the different types of energy conversion. So there are various types of energy all around us, and these energy sources can be converted from one form to another as explained below. So light energy can be converted into heat. Then electrical energy can be converted to mechanical energy, light energy, and heat energy. Chemical energy can be converted to electrical energy. Thermal energy can be converted into heat. Mechanical energy can be converted into electrical and potential energy. Nuclear energy to light and heat. Solar energy to heat, chemical and electrical. And gravitational potential energy can be converted to kinetic energy. So these are just some of the um, conversion na nangyayari on our surroundings. So for some of the examples of energy conversion, we have a vehicle moving is an example of chemical energy being converted into kinetic energy. So how is this possible? So bakit kaya yung moving vehicle is an example of chemical to kinetic energy conversion? Any idea? Kaya nga, any volunteers? So, moving vehicle converted to kinetic energy. Yes, Mr. Mendoza.
Sa combustion process po siguro, sir. Yung sa
So
fuel
it
po.
is okay, so it has something to do with combustion or yung sa fuel natin. So of course, 'di ba, yung ating fuel is a form of chemical. So may mga chemical ano 'yan? Uh, chemical siya. To be exact. Yan. Tapos so kapag binoy natin yung ating sasakyan, so syempre, yung ating fuel na yun yung mako-convert into kinetic energy. So, di ba, pag kinetic energy, so, ibig sabihin, meron siyang movement. So, from static na yung nakahinto lang yung ating vehicle, kapag nagkaroon na ng chemical conversion through the fuel natin, and yung sa internal combustion ng engine, ay di, yun, magkakaroon na tayo ng conversion from chemical to kinetic energy. Yeah. The second one is electricity being produced from water is an example of potential energy being converted into kinetic energy. So, saan naman ito? Electricity being produced from water is an example of potential energy being converted into kinetic energy. Yan. Any idea? Ito ay sa combustion of fuel. And so, paano kaya yung sa ano naman? Water. So sa water, 'di ba, normally ang tubig kasi ay yung stagnant lang. Yan. Or kung moving man siya, yan. So ang ginagawa, especially kapag dams, yan. So 'di ba sa mga dams, ipon yung tubig nila. Tapos meron ka lang mga gate. So, 'di ba kapag close yung gate ng dam, of course, potential energy yung pinopossess ng tubig. But if you open the dam and the water flows, 'di ba? Yung nagmo-move na tubig can be used to run turbines. Yan. So, ibig sabihin, from potential energy, mako-convert siya into kinetic energy kasi moving na yung or flowing na yung water. Then, yung flowing water ngayon, yung magiging pinaka tawag dito, driving force para rotate yung turbine or whatever na connected doon sa dulo ng ating dam or even halimbawa pipes. Yan. Particularly ito sa mga hydroelectric power plants or kahit including yung waterfalls. So, di ba, kalimitan sa mga may falls yan, mga ganyan yung mga ginagawa. And another example is a ball of height towards or from a height towards the ground is an example of potential energy converted into kinetic energy. So, parang ganun lang din yun. Same principle with a waterfall. Then, when you boil water using an electric kettle, it's an example of electric energy being converted into heat energy. Yan. So, di ba, kapag nagbo-boil tayo ng tubig, so, for example, halimbawa ay electric heater nga or electric kettle, yung energy from the supply will be converted into heat energy. So, these are just some of the modern examples of energy conversion. Now, let's take a look at how energy conversion technology has evolved over the years and how the early humans used energy conversion by harnessing the natural forms of energy. So, this one is the evolution of energy conversion. So, nagsimula daw ito sa paggamit ng fire or ng apoy. So the first evidence of energy conversion from early ages is when the ancient humans discovered the use of fire. So they burned dried plant, wood, and animal waste and used the resultant energy for cooking and heating. Of course, di ba kapag halimbawa gumagamit tayo ng apoy, yung apoy itself, yan, di ba halimbawa, yung pag-burn ng plant, ng wood, or anything na panggatong, yan, meron na agad yung chemical reaction. So, ibig sabihin, may nagkakaroon tayo ng chemical conversion. Yan. So, meron na agad yung conversion of energy. And of course, since fire yan, di ba, ang fire, syempre, mainit. Yan. So, nagkakaroon tayo ng heat as an output. Yan. And this was followed by the use of mechanical energy that was used to harness the energy of flowing water and wind. And however, this generation of mechanical energy with the invention of simple devices came much later, around 2,000 years after human discovered the use of fire. Then, sumunod doon is the use of water wheels. So, the earliest evidence of a machine being used to grind grain is that of a water wheel. So, nakita na ba kayo or kahit sa picture man lang ng water wheel? This is somewhat like a turbine or yung nakikita natin, yung mga turbine natin. But this is solely used siya most mga milling plant. Yan nga, pang grind ng ng mga grain. Kaya naman ay parang pinaka-pump siya ng tubig. Yan, kaya siya water wheel or dahil siya ay pinapaandar ng tubig. And this is also used to drive sawmills and pumps, driving tilt hammers or for forging iron, etc. So water wheels were the primary means of mechanical power production, rivaled only occasionally by windmills. Therefore, many industrial towns, especially in early America, were set up at a location that assured water flow all year. So yan. So doon na malimit makita yung mga water wheels. Then, windmills naman, apart from the water wheels, Windmills were also used as a source of power to replace animal muscle. So windmills are used to in various parts of the world to convert the wind energy into mechanical energy for grinding the grain, pumping water, and draining the lowland areas. So, yan. So this is uh, ano pa, yung mga sinaunang setup. Pero, nung nagkaroon tayo ng tinatawag na Industrial Revolution, of course, marami na dito na-discover na kumbaga mas advanced na mga equipment na pwede makatulong dun sa energy conversion. So, such as yung ating steam engine, yung Newcomen engine, the Watts engine. So, yun yung tatlong considered to be uh, yung pinaka-useful na mga engines na na-discover or na-produce during the Industrial Revolution. Yeah. Then, dun sa conversion of energy, now let's understand the law of conservation of energy to further strengthen the fundamentals of energy conversion. So, the conversion of energy is the principle that energy can neither be created nor destroyed. So, it can only be converted from one form to another or transferred from one object to another. So, yan. So, yun yung sinasabi ko kanina. Ideally talaga, your output should be equal to your input. Yan. But, sabi ko nga sa inyo, yung input natin, of course, as it moves towards the output, meron siyang tinatawag na mga losses. Yan. So, syempre, yung input natin, nababawasan siya. So, yun yung mga losses natin. Kaya nga, yung input natin is hindi nag-i-equal doon sa output natin, doon sa actual na setup. So, yan, yung mga transformations such as kinetic energy, potential, light, heat, sound, nuclear, gravitational, potential energy, and etc. So, this transformation would occur again and again till the time of resource is present there. So, until such time na meron tayong input, na meron nag-i-input sa kanya, so meron pa rin energy conversion. The friction effect and air pressure are the other factors which can affect the transformation to some extent. But we will not be dealing with those variables kasi hindi naman yan talaga, kumbaga, hindi siya kasama dun sa mga i-discuss natin ng mga lesson when it comes to energy conversion or kahit dun sa kapag nandun na tayo sa part ng generators and motors. So, magnetic matter attracts magnetic materials but not ferromagnetic materials, and magnetism is a non-contact force that acts as a distance. And so, let's proceed to magnetism and electromagnetism. So, siguro naman, you are all familiar with magnets, right?
Opo, sir.
Okay. So, magnetism is defined as the ability to attract iron and steel. The knowledge of magnetism goes back to the ancient Greeks who realized that a certain rock called lodestone attracted pieces of iron. So when they hang a piece, when they hang a piece of this material, it rotates until it is pointing on the north-south direction of the earth. And magnets are named after the town Magnesia district in Thessaly in Lydia, Asia Minor, where the lodestone or iodestone was mined in the ancient time. The natural permanent magnets were called lodestone, and then after the iode star or the guiding star. Lodestone was the first permanent magnetic material to be identified and studied. And the regions near the end of the magnet is called the pole. Yan. Kaya kung mapapansin nyo, yung magnet natin ay lagi merong north and south pole. So some of the known magnetic materials are iron, steel, nickel, and cobalt. Yan. So now let's proceed with the classification of matter according to the magnetic property. So magnetic properties of matter arise from the alignment of the atomic or molecular spins generating magnetic field. So yan. So Depending upon kung ano yung molecular alignment or atomic alignment ng ating material, so doon ngayon magdi-determine kung anong klaseng material ang meron siya or yung matter natin as to its magnetic property. So, meron tayong tatlong classification ng matter according to its magnetic property. We have the ferromagnetic, paramagnetic, and diamagnetic. So, let's discuss firstly ferromagnetic. So, ferromagnetism is the basic mechanism by which certain materials such as iron form permanent magnets. Yan. So, yung ferromagnetic material daw are called permanent magnets. So, this means this compound shows permanent magnetic properties rather than exhibiting them only in the presence of the external magnetic field. So, ibig sabihin, innate na sa kanya or natural na sa kanya na yung magnetic property. So, in ferromagnetic element, electrons of atoms are grouped into domains in which its domain has the same charge. And in the presence of the magnetic field, these domains line up so that the charge are parallel through the entire compound. Whether a compound can be ferromagnetic or not depends on its number of unpaired electrons on its atomic size. So, the materials such as cobalt, nickel, iron are put near a magnet, they begin to act like other magnets. So, ganito daw yung setup natin when we are talking about ferromagnetism. So, kung mapapansin natin dito, yan. So, this is the non-magnetized material. And as you can see here, yan, meron na tayo dito mga dito. So, ito yung mga group of atoms natin. Yan, same charge yan. And makikita natin, hindi siya naka-line up. And so, ibig sabihin, hindi pa siya na ma-magnetize. But, kapag isinubject natin itong material na to into a magnetic field, yan, such as this one, so mapapansin nyo, nag-a-align parallel yung ating, yan, itong mga to, dun sa ating magnetic field. Yan. So, in one direction na lang yan, tapos parallel siya dun sa ating magnetic field. So, kapag ganito na yung setup natin, ibig sabihin na magnetize na yung ating material. Yan. Then, ferromagnetism, the magnet or the permanent magnetism associated with nickel, cobalt, and iron is a common occurrence in everyday life. Then, examples of the knowledge of and application of ferromagnetism includes Aristotle's discussion in 625 BC, where the use of compass in 1187 and the modern day refrigerator. So, yan daw yung mga common na mga applications ng ating permanent magnet. Then, the second classification is what we call diamagnetic. Diamagnetic substances are characterized by paired electrons, pero yan, wala daw siyang unpaired na electron. Laging paired daw yung kanya. According to the Pauli exclusion principle, which states that no two electrons may occupy the same quantum state at the same time, the electron spins are oriented in opposite direction. And this occurs, the magnetic fields of the electrons to cancel out. And there is no net magnetic moment, and the atom cannot be attracted into a magnetic field. Yan. So, since opposite yung direction ng electron spin, ibig sabihin, magka-cancel out lang yung kanyang value. Ibig sabihin, walang net magnetic moment. Yan. So, di ba, halimbawa, yung isa pa kanan, yung isa pa kaliwa, kung parehas sila ng magnitude, different lang ang direction, magka-cancel out lang yung dalawang yan. So, diamagnetic materials have the ability to slightly repel magnetic field, and Faraday discovered that this material in 1845. He found out that bismuth and glass are repelled from magnetic field. So, these two are some of the example of diamagnetic material. And when we say paramagnetic material naman, paramagnetism refers to the magnetic state of an atom with one or more unpaired electrons. The unpaired electrons are attracted by a magnetic field due to the electric magnetic dipole moments. Then, Hans' rule states that the electron must occupy every orbital singly before any orbital is doubly occupied. Yan. So, kailangan ma-occupy daw muna siya singly before it is occupied doubly. Then, this may leave the atom with many unpaired electrons, and because unpaired electrons can spin in either direction, they display magnetic moments in any direction. So, this capability allows paramagnetic atoms to be attracted by magnetic field. Also, Faraday, or discovered by Faraday, he noted that some substances clearly not permanent magnets are nevertheless attracted by magnetic fields, and these materials are named paramagnetic. So those are the three classifications of materials according to its magnetic property. So we have ferromagnetic, paramagnetic, and diamagnetic material. Do you follow? Are you still there?
Yes po.
Yes po, sir.
How about the others?
Yes po, sir. Yes po, sir.
Yes po, sir.
Okay. So, let's talk about magnets naman. Yan. So, nakakita na ba lahat ng magnets? Or nakahawak na ba lahat ng magnet? O meron
Yes
dito
po.
hindi pa nakakakita ng magnet. Yan. Familiar naman lahat sa magnet. So, magnet can come in different forms or in different shapes. So, meron tayo yung wire magnet lang, meron tayong horseshoe na magnet, yan, uh, and many more. So, yan. So, a magnet is any object that has a magnetic field, and it attracts ferrous objects like pieces of iron, steel, nickel, and cobalt. One of the most common magnets, which is the bar magnet, is a long rectangular bar in a form of uniform cross-section that attracts pieces of ferrous objects. And this magnetic compass needle is also commonly used. The compass needle is a tiny magnet which is free to move horizontally on a pivot. One end of the compass needle points to the north direction and the other points to the south direction. The end of the freely pivoted magnet will always point in the north-south direction, and the end of that points in the north is called the north pole of the magnet, and the end that points south is called the south of the magnet. And it has been proven by experiments that like magnetic poles repel each other whereas unlike poles attract each other. So yan. So kung mapapansin nyo dito sa ating tawag dito. Yan. So dito sa ating given, so the region around the magnet is a magnetic force can be felt is called the magnetic field. So ito, 'di ba? Ito yung ating magnet, so ito yung bar magnet natin. And so ito yung geographically, 'di ba? North pole ito nasa taas is the north. Tapos ito is yung nasa baba is yung ating south. Tapos yung ating magnetic pole, ito yung north natin, ito naman yung south. Ayan. So, magnetically, di ba confusing? Yan. Confusing siya kasi ito daw south, yan, magnetic north pole siya. Tapos ito naman kabila, magnetic south pole. Yan. So, di ba medyo confusing? But, yun nga, ito kasi yung south pole nito is, di ba sabi nga din opposite attracts and like poles repel. So, ibig sabihin, kaya attracted itong south pole ng ating magnet to the north pole or to the geographic north pole is because nga magkaiba sila ng pole. So, this is south, this is north. But, the south pole of the magnet is the magnetic north pole naman. Yan. So, yan yung ating sa comparison. Kaya kung mapapansin natin, yung compass natin always points to the north direction. Yan. So, lagi siya nakapoint sa north. And sabi dito, the magnetic field is strongest at the poles of a magnet. So, ano nga ba yung magnetic field? Magnetic field tayo ng magnetic field. Ano ba yung magnetic field? So, this is a space surrounding a magnet in which magnetic force is exerted. If a bar magnet is placed in such a field, it will experience a magnetic force. However, the field will continue to exist even if the magnet is removed. And the direction of the magnetic field in the direction is the direction of the resultant force acting on a hypothetical north pole placed at that point. So, the magnetic field around a bar magnet has a shape and direction. So, mapapansin natin if this is our uh, magnet. Yan. So, di ba kung mapapansin yung magnet natin, lagi may hati yan. Or ang ginagawa is magkaiba yung kulay. Yan. So, merong pula at merong blue na pole. Yan. So, dito, kung ititrace down natin, ang direction ng ating magnetic field is always from north to south. Yan. From north to south. Yan. So, ito yung direction ng ating magnetic field. At lagi yan na ganyan yung lagi niya magiging setup. So, concentrated siya. Of course, pinakamalakas nga yung direction ng ating or yung intensity ng ating magnetic field dun sa mismong pole ng ating ng ating magnet. So, the magnetic field is represented using magnetic field lines or lines of force or flux lines that shows the shape, direction, and strength of that field. Yan. So, speaking of magnet, so if we have a bar magnet, sige. So, if we are going to have a bar magnet, yan. So, ito si bar magnet, tapos ito ay si north, ito ay si south. What if maputol yung bar magnet natin? Ano mangyayari sa kanya? Any idea? Kasi di ba, yung magnet natin ay north at south. So, ibig sabihin ba kapag ka naputol yung magnet mo, north na lang yung isa, south na lang yung isa? Yes, anyone?
Pagkakaroon po sir ng mga bagong poles, di po siya magiging north lang po at hindi rin po siya magiging south lang. Magkakaroon po ng bagong north at south pole po pag nasira po yung magnet.
Okay. So, ibig sabihin, since pinutol natin, originally this is the north pole, di ba? So, magkakaroon siya ng sarili niyang south pole. So, same with this one. So, magkakaroon siya ng north pole, magkakaroon siya ng south pole. So, since itong dalawang ito are unlike poles, so it is likely to attract each other. Right? So, yan. So, yun yung mangyayari sa magnet. So, hindi po possible na magkaroon lang ng isang pole ang magnet natin. So, lagi siyang mayroong north and south. So, paano daw nagkakaroon ngayon ng magnetic field? So, when current flows in a wire, a magnetic field is created around that wire. And from this, it has been inferred that magnetic fields are produced by the motion of electrical energy. And the magnetic field of a bar magnet thus results from the motion of the negatively charged electrons in the magnet. And magnetic fields are produced by electric currents, which can be macroscopic currents in wires or microscopic currents associated by electrons in the atomic orbit. And the magnetic field, represented by beta, is defined as in terms of force on moving charge in the Lorentz force law. So the interaction of magnetic field with charge leads to many practical applications. And the magnetic field sources are essentially dipolar in nature. So ito yung sinasabi ko sa inyo. Having the north and south magnetic pole. Dipolar hindi bipolar. Dipolar meaning meron siya laging dalawang pole. So kaya ngayon tinanong ko kanina, kung ang magnet natin ay maputol, so magkakaroon siya ng sarili ng north pole and south pole. Okay? Ayan. And we have the absolute permeability and relative permeability of a medium. When we talk about permeability, so it is defined as the ability of a material to conduct magnetic flux through it. And a material's magnetic permeability refers to its ability to align itself with a magnetic field. And a high magnetic permeability indicates that a material easily aligns itself in a magnetic field. So, ibig sabihin, highly attracted yung material natin to a magnetic field. So, if it is difficult to align to the magnetic field, the material is said to have low magnetic permeability. So, ibig sabihin yung mga attracted sa ating mga magnets, yung mga na-attract na magnets such as iron, steel, yan, yung mga yan, matataas ang kanyang permeability. Then, the magnetic permeability can be taught as how easily material can be magnetized. So, say for example, glass. Yan. Can glass be magnetized? Namamagnetize ba ang glass? Namamagnetize ba ang glass?
Hindi po, sir.
So, di ba hindi? Kahit anong gawin mo doon, kahit anong dikit mo ng magnet dyan, hindi siya mamagnetize. Unlike sa iron, halimbawa, yung nail. Yung nail, kapag nilapitan mo siya ng magnet, ang tendency ng iron is to be attracted by the magnet. Tama? Then, yung mga nails na nakakabit sa magnet, di ba kahit yung dulo ng nail na yon can also attract any other materials na magnetic. So, yan. Then, kapag tinanggal mo na yung magnet sa kanya, may tendency pa rin na maging magnetic yung nails na yon. Kasi nga, nare-retain niya yung kanyang magnetic field. So, kaya minsan, kahit natanggal mo na yung source ng magnetism o yung source ng magnetic field, na-attract pa din or dumidikit pa rin yung mga materials or halimbawa yung iron or any steel material dun sa ating other material. Right. So magnetic phenomena or the phenomena of magnetism and electromagnetism are dependent upon certain property of the medium called its permeability. And every medium is supposed to possess two permeability, namely the absolute permeability or the mu O or mu naught and the relative permeability or the mu R. So, pag sinabi nating absolute permeability mu O, in electrostatics, permeability is the measure of the ability of the material to allow the formation of magnetic lines of force or magnetic field within. So, ibig sabihin, pagtaas ng permeability nga natin ng material, pagtaas din ang tendency of the material to be magnetized. Then, absolute permeability refers to the permeability of free space. Kaya nga siya mu O. And the absolute permeability is a constant and it gives or its value is given as 4 pi times 10 to the 7 Henry or constant 33 on your calculator. So, kapag pinindot natin siya sa calculator, right? So, ano nyo lang, shift 733. Right. So, paki-correct lang yan, this should be negative 7. So, that is 4 pi times 10 to the negative 7 or 1.256637061 times 10 to the negative 6 Henry per meter. Paki-correct nito ha. Yung 4 pi times 10 to the negative 7. Okay? Naliwanag po yun.
Yes po. Yes po, sir.
So, ano ba nangyayari? Ano ba yung magnet natin? So, diba, syempre, kapag, balik muna tayo dito sa magnet. So, yung magnet natin, of course, di ba, yung sa drawing kanina, if you have a magnetic field like this, so, you have a north and south pole, di ba, sabi nga natin, yung direction ng ating magnetic lines or magnetic lines of force ay laging from north to south. Yan. So, lagi siyang pupunin yan. Yan. So, lagi pa rin siyang from north to south. As concentrated na siya dito, so, direction pa rin niya is from north to south. Then, so, kapag nga we have two magnets, yan, na nakaganito, yan. So, anong mangyayari doon sa kanyang magnetic field? So, since itong dalawang ito is also, di ba, magkaibang poles pa din naman ito. Di ba? So, magkakaroon ng attraction. Of course, itong part ng ating magnet will have its own magnetic field. Yan. So, ang mangyayari doon is that magkakaroon ng attraction between dito sa dalawa. So, magkakaroon siya. Kumbaga, mag-merge ngayon yung magnetic lines of force nitong dalawang ito. Yan. Magkakaroon siya ng sarili niyang lines of force. And of course, yun ay from north to south pa din. Yan. So, ganyan yung magiging itsura. Tapos, syempre, ito, magkakaroon din siya ng sarili niyang kasi di ba north and south pa din naman yan. North-south pa rin yan. So, magkakaroon pa rin siya ng sarili niyang magnetic field from north to south. Yan. So, ganyan yung mangyayari sa ating magnet. So, pagka naman unlike pole ang nangyari, like poles, halimbawa, north-north. North-north, north-south. So, itong dalawang ito, since ito ay magkaparehas, so, di ba, like poles, repel naman. So, tendency niya is to repel the magnetic field. So, hindi mag-meet yung dalawang o yung mga lines of force natin dyan. Yan, lagi siyang yan yung mga pinagtagpo pero di tinadhana. Yan. So, hindi siya mag-meet. Lagi lang siyang may gaya. Mare-repel lagi yung kanyang magnetic field. Yan. So, and the direction is also from north to south. So, ganyan lang yung mag-nature. And so, ito, magkakaroon din siya ng sarili niya magnetic field. So, from north to south ulit. So, ganyan lang yung mangyayari. And, during your first day, kayo ba ay nag-conduct na ng experiment about magnets?
Yes po.
Kapag punta kayo. Okay, so you have seen this, this one. Yung,
Opo, sir.
okay, so yung alignment ng magnetic lines or magnetic field lines. And although hindi nyo naman makikita talaga exactly yung arrow-arrow na yan, yung arrow hindi nyo makikita yan sa actual, but then, yung itsura ng magnetic lines, of course, ay makikita natin by using that experiment. Okay? So, yan. So, that is for our magnets and magnetic field. And so, let's go back to the permeability. So, when we talk about naman relative permeability or μr, it is the ratio of the permeability of the substance to the absolute permeability. And the ratio of the permeability of the substance to the permeability of vacuum is what we call now the relative permeability. So, ang μr natin is equal to mu divided by μo, where μr is the relative permeability, mu is the permeability of the substance, and μo is the permeability of the vacuum. So, it is important to take note that the relative permeability is a dimensionless quantity. Kasi nga siya ay ratio. So, ang mu natin is Henry per meter, ang μo natin is also Henry per meter. Therefore, magiging unitless ang ating relative permeability. Okay? Ayan. And, kapag naman ang i-note natin, say for example, na kapag ka ang relative permeability of a vacuum with reference to itself is unity. So, ibig sabihin, kung susundin natin ito, and so, for free space, ang μo natin is 4 pi times 10 to the negative 7 Henry per meter. And ang relative permeability naman, mu r is equal to 1 kapag ang pinag-uusapan natin ay air or vacuum. Tatandaan nyo yan ha. So kapag po ang pinag-uusapan natin ay with respect to air or vacuum, ang mu r natin ay 1. So take note din natin that using this equation, kung i-rewrite natin siya, if you are going to get the permeability of any medium other than vacuum, then your mu should be equal to mu O times mu R. Yan. Take note natin itong ating mga formulang ito. Ganyan pa. So, break muna tayo ng mga 5 minutes just to para pahinga din ang boses ko. So, we will be back at around 6:35. And we will continue with our lesson on magnetic lines of force. Mike, give you ulit Okay, so let's continue with our discussion. So let's have the flux per unit pole or the magnetic lines of force. So just as an electric field is described by drawing the electric lines of force, in the same way, magnetic field is described by drawing the magnetic lines of force. So when a small north magnetic pole is placed in the magnetic field created by a magnet, it will experience a force. And if the north pole is free, it will move under the influence of that magnetic field. Then, the path traced by a north magnetic pole free to move under the influence of the magnetic field is called or the magnetic lines of force. In other words, the magnetic lines of force are the lines drawn in a magnetic field along with the north magnetic pole that could move. And the direction of the magnetic line of force at any point gives the direction of the magnetic force on the north pole placed at that point. And since the direction of the magnetic lines of force is the direction of the force, the North Pole, so the magnetic lines of force always begin on the North Pole of a magnet to the end on the S pole of a magnet. Kaya nga kanina, nung nag-drawing tayo, nag-drawing tayo kanina, di ba lagi kong, ang drawing ko ay ang arrow niya is from the North to the South Pole direction. So a small compass or magnetic compass when moved along a line of force always sets itself along the line tangential to it. So sabihin, di ba, tangent yun. So it, a line drawn from the south pole of a compass to its north pole indicates the direction of the magnetic field. So kaya kapag ginagamit din yung compass kasi meron experiment doon. Halimbawa, ito yung bar magnet natin. So, maglalagay ka dyan sa paligid niya ng mga compass. Then, makikita nyo mo dyan kung saan mag-move yung direction ng compass. So, lagi niyang ituturo yung north pole. So, di ba, dalawang end ng compass natin. So, ang lagi niyang ituturo is towards the north pole of the compass. So, mag-iiba-iba sila ng direction. So, merong nakatuwid, merong nakaslant. Yan. So, depending upon dun sa, natin, sa placement ng mga compass around a magnet. Kasi nga, may magnetic field. Yan. Diba? Ito, magnetic field. So, kapag nilapit natin yan, yung compass natin, so makaka-experience na yan ng magnetic field. So, tangent, kaya nga siya sinabing tangential, ibig sabihin, i-align niya yung compass, yung sarili niya to the, or yung needle na yan is mag-a-align yan to whatever direction of the magnetic field ang meron tayo. So, tangential siya dyan. Okay? Liwanag po? So, So, what are the properties of the magnetic lines of force? So, the magnetic lines of force originate from the north pole of a magnet and ends at its south pole. Magnetic lines of force come closer to one end near the poles of a magnet, but they are widely separated at the end of other place or at the other place. Meaning, kaya closer yung ating magnetic lines of force dun sa end kasi dito nga yung strongest, yan. So, yan yung strongest part ng ating magnetic field. And the magnetic lines of force do not intersect or cross one another. Kaya kung mapapansin natin dun sa ating mga drawing, yan, wala pong nagpapatong or nag-meet ng mga lines of force. Lagi lang siyang in parallel with each other. Yan. Tapos katulad nito, so 'di ba nung nagkaroon tayo ng light poles, never silang mag-meet, yan, hindi sila magta-touch with each other. So yan po yung characteristics ng ating magnetic lines of force or dun sa ating magnetic field. So yan. Now, so ito ay magsisimula yung ating mga computation dito sa ating topic. So, although this one will be just the review nga, yan. So, siguro naman as prior experience, so marirecall nyo na kung paano ginagamit ah, itong ating mga formula dito or yung mga constant or yung mga variables na ginagamit. Okay? So, yung magnetic flux natin, pag sinabi natin magnetic flux, it is the number of, or before pala introduce itong mga to, so, sabi ko sa inyo, di ba, last time, so we will be utilizing 3 different units of measurements or systems of units na gagamitin natin dito. So, ano yung tatlong yon? Sige nga, if you may recall, ano yung tatlong systems of units na ating gagamitin or na ating ginagamit for problem solving? Anyone na nakaka-recall? Anyone? Or may nakikinig pa ba sa akin? So, kaya rin kasi ako nagre-request ng at least man lang ay meron tayong face-to-face talaga ay dahil nga, katulad nito. So, I am asking questions. I don't see anyone since your cameras are off. So, I don't know if you're still there or baka mamaya bukas lang yung inyong computer, laptop, or cellphone. Pero wala naman kayo talaga dyan sa inyong or wala naman kayo sa harap ng gadget. So, sana wag nating i-take lightly yung subject or lightly yung subject kahit pasabihin natin that this is your second take. Hindi porke second take na kayo dito means that you will surely pass the subject. Kaya nga, the last time I conducted a meeting with you, I specifically requested if possible talaga is paki-open ng camera. Especially na, katulad nga nito, 5 to 8 yung ating klase. So, baka mamaya tulog na kayo. Wala na pala akong kausap. Diba? So, at least, if you open your cameras, then I will be able to know kung talaga nakikinig kayo sa akin or hindi. Yes, Mr. Alama.
Ang tanda ko naman po ay SI po at English.
Okay. So, ano pa yung isa?
Hindi ko po matandaan po ang isa. Nakalimutan ko po.
Okay. So, yung isa is what we call yung sa CGS unit. Although halos same lang din naman sa SI. Diba? Meron tayong tinatawag na SI unit or SI system or the System International. Yan. So, SI or yung tinatawag din natin siyang MKS unit or yung meter, kilogram, second. Then, we also have the CGS units, yan, which is centimeter, grams, and second. Then we have our English system. So we have pounds and or feet or inches, pounds, and second. So yan yung tatlong systems na kailangan nating maging familiar dito sa ating magiging discussion sa ating mga topics later on. And so we have the SI unit, the CGS unit, and the English system. Okay? Maliwanag po?
Yes po.
Yes po.
Yes, sir.
Yes po.
So let's proceed now with the magnetic flux. So pag sinabi natin magnetic flux, it is the number of magnetic lines of force in a magnetic field. And Maxwell is the unit of magnetic flux which is equivalent to one line of force. Yan. So, kung dissect daw natin itong ating mga form or yung ating mga unit na to. And so please take note that Maxwell is in CGS unit. And yung lines or line of force is in the English system. Yan. So English yan. And the Weber is SI. So please take note of that ha. So kung ano daw natin, so if 1 Maxwell is equivalent to 1 line of force, yan, ang Weber daw natin is the SI unit of the magnetic flux, which is equivalent to 10 to the 8 lines or Maxwell. So, ang 1 Weber is equivalent to 1 times 10 to the 8 Maxwell or 1 times 10 to the 8 lines. Yan. So, yan daw yung equivalent or conversion factors na meron tayo when we are going to convert yung ating magnetic flux from one system to another. Again, so Maxwell is for the CGS unit, lines is for the English system, and Weber is for the SI. So the following conversions and values or constants will also be useful kapag nagsasolve na tayo ng mga problems or mag-solve na tayo ng mga problems later on. So we have the charge for or Q for charge equivalent to 1.602 times 10 to the negative 19 coulombs. Ang 1 kilogram force is equivalent to 9.81 Newton. Ang 1 Newton is 10 to the 5th times. Ang 1 pound force is 4.448 Newton. And ang 1 Tesla is equivalent to 10 to the 4 Gauss. So, mamaya natin pag-usapan anong ba yung meron dyan sa Gauss, ano yung times, Newton na yan. So, let's go to the flux density. So, nare-recall nyo naman itong mga conversion factors na ito and units.
Yes po.
Yes po.
Yeah. Then we have the flux density. So it is given by the flux passing per unit area through a plane at right angles to the flux. Right. So take note na right angles daw yung pinag-uusapan natin dito. It is measured in Weber per meter squared or this is equivalent to what? Sige nga, as you may recall, anong equivalent ng Weber per meter squared? Okay. Pwede din naman yan. So, as a unit, that is in Tesla. Okay. So, ang formula daw natin to find the magnetic or the flux density is equal to, sabi na dito, that is the flux per unit area. So, that is the flux per unit area or flux divided by area. Can also be found by using the formula mu times H, where H is the magnetic field intensity, which we'll be discussing later. And as you may recall, ang mu natin or the permeability of the material is mu O times mu R. So therefore, the flux density can be also computed using mu O mu R times H. So the direction of the magnetic field at any point is defined by the direction of the motion of a charged particle on which the magnetic field would not exert force. And the magnitude of the magnetic field vector is proportional to the force acting on the moving charge, the magnitude of its velocity, and the angle between velocity and the magnetic field. Units are Tesla or Gauss. So sa English system, wala siyang equivalent. Yan. So, di ba, ang equivalent or ang ating flux density is flux per unit area. So, sa SI unit, ang unit ng flux is Weber. Ang area ay meter squared. So, that is Weber per meter squared or Tesla. In CGS naman, we have the flux in Maxwell. Area in centimeter squared, equivalent to Gauss. Tapos, pag English naman, that is, yung flux natin is in line. Tapos, ang area natin is in inch squared or feet squared. Okay. Then we have the electromagnetism. So first muna nating sorry, muna natin yan. Medyo nagkaroon lang ng ano dito. So magsimula muna tayo dito sa force on a charge. So ito kasi dapat talaga unahin natin since ito ay sa given charge lamang. So if you're going to have this, so force on a charge, that is the amount of attraction or repulsion between charged object, can be put in quantitative terms by the introduction of the electric force. The simplest case to consider is the force between 2-point charges or charges which negligible size. Yeah. So, kapag pinag-usapan natin yung force natin, and yung magnitude of the force can be computed. So, since yung force kasi natin is, this is a vector quantity. So, di ba? Pag sinabi natin vector quantity, so, ano ibig sabihin ng vector quantity? Yun nga. Ano ang meron sa kanya kapag vector quantity? There should be letter M and
Magnitude po at direction.
okay. So we have magnitude and we also have a direction. So ibig sabihin, kailangan natin ma-identify what is the magnitude of that force and also its direction. So, yan. Ang force natin, itong formulang ito, the force is equal to the given charge multiplied by the velocity, wherein yung velocity natin is a vector quantity multiplied by a flux density, which is also a vector quantity multiplied by sine of theta. Yan. So, bakit may sine of theta doon? Yan. So, ibig sabihin, kung pag-uusapan natin ito, paano mo malalaman o paano mo matatandaan ang formula kapag force on a charge yung ating pinukuha. So, ang tinatandaan ko lang dyan ay are. Yan. So, anong basa dyan? Ito. So, ang tinatandaan lang natin dyan, kapag charge ang pinag-uusapan, ang force nun ay sino bibiko. Yan. So, sino bibiko. So, flux density, velocity, at charge. Then, yung sine theta, so, kasi ang force, di ba, kapag ang sine theta natin, since sine yan, kailan siya magiging 1? Kailan magiging 1 ang value ng sine theta? Kapag ang theta ay equal saan?
$90 po.
Okay. So, di ba kapag 90 degrees? So, ibig sabihin, there should be a 90-degree angle. Yan. So, ang mangyayari doon, kailangan maging perpendicular yung ating velocity at saka yung magnetic field. Yan. So, syempre, maximum ng ating force kapag siya ay 90 degrees. And paliit naman siya ng paliit kapag siya ay habang lumiliit din yung angle between them. Tapos, syempre, kapag nag-coincide na yung ating magnetic field at saka yung velocity ng ating charge, ibig sabihin, magiging 0. Kasi di ba parallel na sila? So, ang sign of 0 is 0. Therefore, wala nang force na mag-a-act doon. Okay? Yan po yun. So, ang magnitude po doon is sino bebe ko. Yan. So, sa Lorentz right-hand rule, so this states or this can be used to describe the effects of a charge particle moving at a constant magnetic field. So in an open right hand, the direction of the forefingers points toward the direction of the magnetic field, and the thumb pointing perpendicular to the point fingers points to the direction of the magnetic force. In a positive charge is in the direction which the open the palm will push. Alright, so ito daw ang gagamitin natin. So the implication of this expression includes the force is perpendicular to both the velocity and velocity of the charge in the magnetic field, kagaya ng sinabi ko kanina. Yeah, perpendicular dapat yan. Yung velocity at saka yung magnetic field. Then, the magnetic force, so F, or the magnitude of the force, where theta is the angle, which should be less than 180 degrees between the velocity and the magnetic field. This implies that the magnetic field on a stationary charge, kapag hindi gumagalaw yung charge, or charge moving in parallel is zero. Yan. Kasi nga, kapag parallel or hindi umiibo ang charge natin, walang velocity, zero din ang kanyang force doon. And the direction of the force is given by the right-hand rule, and the force relationship above is in the form of a vector product. So, kaya nga sabi ko sa inyo kanina, ang force natin is a vector kasi yung velocity natin dito at saka yung ating magnetic field ay parehas din ng vector 1. Yeah. So, ito yung mga ano natin. So, ang magnetic flux natin, beta. So, we have beta per meter squared, Maxwell per cm squared, or Gauss, lines per square inch. Then, yung force natin is a Newton, dynes. Yan. So, ito ay yung SI, CGS, at saka English. So, we have yung force natin in SI is Newton, tapos si dynes, sa CGS, tapos pound force kapag English. Then, the velocity naman is meter per second, centimeter per second, tsaka inch per second or feet per second. So, yan po yung ating ginagawa. Tapos, in order to find the direction yan, of the force, so di ba ito, yung F is equal to QVB or sino bebe ko is para lang sa magnitude. Okay. So, this is for the magnitude of our force. So, paano mo ngayon makukuha ang direction ng force natin? So, say for example, and so, gagamitin natin yung tinatawag nating right hand rule. So, sa right hand rule, so kindly open your cameras po para mas makita natin. Paano nyo gagawin ito? Sige nga, paki-open po ng camera ng everyone. Can everyone please open their cameras para dito sa sample problem natin para mas madali yung maintindihan. Okay, so the others are not. Okay. So, to execute the right-hand rule, so meron tayong right-hand rule na tinatawag. So, all you have to do is to use your right hand, of course. I don't know if, ano ba, tama ba ang pagka, sa inyo, ang harap niya. So, ito ang aking right hand. Ayan. So, all you have to do is to point your fingers on this way. So, yan. Ganito yung gagawin natin. Yan. So, yan. Makikita nyo. Ayan. So, may thumb is pointing upward. Tapos yung aking point finger is pointing toward the monitor. Tapos yung aking middle finger is towards the left. Yan. Towards the left ha. Baka kasi baliktad dyan sa inyo. Yan. So, upward are. Tapos yung point finger ko is towards the monitor. Tapos ito is to the left. Yan. So, anong magiging notation natin? So, yung point finger ko is on the direction of the velocity of the particle. Kindly take note. Velocity po yung aking point finger. Tapos, itong aking middle finger is the direction of the magnetic field or ng ating beta. Tapos, yung ating thumb will be the direction of the force. Yan. So, say for example, if we're going to look at the we're going to look at your so, dito sa ating example. So, paano yan? So, all we have to do is to sundin lang natin yung mga directions given by this given. Yan, yung given natin. So, paano yun? So, mag-umpisa tayo kay velocity. So, si velocity daw natin is pataas. Yan. So, naka-point yung finger ko pataas. Yan. And, yung magnetic field ko daw is going to the right. So, going to the right, so I will rotate my hand so that the direction of the magnetic field is to the right. Now, what is the direction of the force? So, kung ang aking velocity is upward, ang magnetic field ko ay to the right, and the direction of my force is saan?
Forward, sir.
Towards saan? So, if my reference is the monitor, then the direction is towards the monitor. So, kung ang reference mo naman ay sa papel, halimbawa kung papel yan, so pataas, tapos ang magnetic field ko ay pakanan, so towards the paper. Yan. So, towards the paper siya. Kung ang reference ko ay paper. Okay? Nakuha po yan? So, how about the second one? So, ito naman, ang given naman sa atin is the direction of the force and the direction of the magnetic field. Ang pinapahanap sa atin is the direction of the velocity. So, ito ang pinapahanap sa atin, yung ating point finger. Saan daw siya pupunta? So, ang reference natin ay sa monitor ha. Sa monitor ang ating reference. Saan siya? Ano ang direction ng ating velocity? Anyone? Oh, mag-open naman ang camera yung iba para makita ko. Yes, Mr. Alamag.
Pataas po ba, sir?
Pataas. How about the others?
Towards the
Yes, yes.
monitor po rin po.
Towards the monitor. So, sino nagsabing towards the monitor din? Sino yung nakaano nun?
Same lang din po, sir. Towards the monitor po.
Oh. Yes. Sino yung nag-raise ng hand? So, bakit towards the monitor? So, we are going to consider the right hand rule natin. Yan. So, di ba, ang magnetic field natin, iayos natin yung kamay natin into our rotation. So, ang magnetic field ko daw ay pataas. So, i-rotate ko na pataas siya. Yan. Tapos, ang magnetic force ko daw ay to the right. Di tama naman. Isang rotate lang. Uy, sorry ha, baka iba ang itsura pagka nakaharap sa monitor. Hindi ba? Baka masama kasing tingnan. Sorry ha. Pero hindi yun yung ibig sabihin. I am just demonstrating, pero sorry for the sorry kung ganun ang itsura kasi baka pagka nakaano kayo sa monitor is ganun yung itsura. Hindi yun ganun ha. Ito ay demonstration ng pagkuha ng direction. Yan. So, ito ay upward, yung magnetic field natin. Tapos, to the right ang ating force. So, meaning, ang velocity natin is also towards the monitor. Kung monitor ang iyong reference. Kung ang reference mo naman ay sarili mo, ibig sabihin that is away from you. Yan. So, depende kasi yun sa iyong reference. So, pwede siyang towards the monitor. Yan. Or, away from you. Yan. So, yan yung dalawang possible na sagot. So, may iba pang ways kung paano natin, halimbawa, hindi naman ganito. Yan. Tinuro ba ito sa inyo dati? Pala. Tinuro din ba ito sa inyo dati?
Hindi ko. Hindi ko
Diba
po.
na uli?
Parang hindi po.
Parang hindi ata. So, yan. So, meron pang ibang way to demonstrate this one. So, halimbawa, depending upon the tawag dito. So, magdidepende siya sa kung ano yung configuration or direction ng ating magnetic field. Yung magnetic field natin kasi hindi lagi siyang papaganyan. So, halimbawa, meron kasing dalawang possible ways kung paano mo siya makikita. It's either ganito, yung tuldok lang, o kaya naman ay yung cross mark. Yan. So, ibig sabihin, this is like the representation of an arrow. Yan. Yan. So, bakit ganyan ang naging representation niya? So, an arrow. Kapag ang arrow ay papunta sa'yo, or nakatingin ka sa arrow na papunta sa iyo, ang makikita mo lang dyan ay yung point. Or bilog lang siya. Bilog lang yung makikita mo sa kanya. Pero kapag ang arrow ay palayo sa'yo, ang makikita mo lang dyan is yung tail ng arrow. So that is represented by X. Magnetic fields are also, or magnetic flux density, or simply flux density can also be demonstrated or illustrated in that way. So halimbawa, ganito. So kapag ganito ang aking magnetic flux, yan. Tapos, ang velocity ko ay pataas. Yan. So, what is the direction of the force? Sige nga. Try nyo nga yan. So, ang ating nakikita ay arrow na tail. So, ibig sabihin, ang magnetic field mo ay away from you. Tapos, ang velocity ko daw ay pataas. So, saan daw pupunta ngayon ang aking force? Yan, try nyo nga yan. So, naintindihan yung configuration natin. What is the direction of the force?
Pero towards the left po.
How about the others? Anong sagot niya?
Sa
Left
left
din
din.
po.
Pa-left po.
Opo, kaliwa.
Bakit to the left? Natin, ang velocity mo ay pataas. Tanggalin nga natin yung background. Ano tinatanggal yung background dito? No, hindi mo natanggal yung background. Yan. So, upward ang direction ng velocity. Tapos, ang magnetic field is towards or away from you. So, the direction of the force is to the left. Nakuha? Nakuha po yun?
Opo, sir.
Yes
Yes
po.
Yes po.
Yes po.
The left. So, halimbawa naman ay are. Ayan yung direction naman natin is pakanan. Pakanan ng velocity, away ang
Pataas po.
away from you. O, pataas daw. With the others.
Pataas po. Pataas din.
Okay. So, bakit? So, away from you ang magnetic field, to the right ang velocity, therefore, upward ang force. Okay? This is upward. How about naman kapag ganito? Yan. So, towards you naman ang given magnetic field, pababa ang velocity, pasaan ang iyong magnetic force.
Towards the left po.
How about the others?
Pakaliwa po. Left po. Left po.
Okay, so this is to the left. So how about this one naman? So your velocity is to the right, your magnetic field is to the right then. What is the direction of the force? So, ano ng direction ng force natin? So, parehas to the right ang velocity at ang magnetic field. Ano, nalito na.
Pataas.
Pataas po, sir.
Pataas. Pataas daw. How about the others? Pataas ba? So, upward is wrong. Mali yung
To the
pataas.
right. To the right po lahat.
To the right. Hindi rin. Mali din yun. Oh, no force daw, sabi ni Mr. Austria. Bakit? So, bakit walang force, Mr. Austria? Sabi ni Mr. Kagas, downward daw. Hindi. Walang 8, Mr. Austria. Hindi ko alam kung sa akin lang or...
Hello po, hello.
Yan, sige, continue.
Perpendicular po ata dapat.
Okay. So, yan. So, yun yung kanina ko sinasabi na yan. So, di ba sa configure or sa tayo ng ating kamay, yan, kung mapapansin natin, ang nire-represent natin is that three fingers are always perpendicular to each other. But then, hindi po laging ganun ang case. Ang dapat lamang po ay perpendicular si velocity at si force at si magnetic field. Pero hindi po laging perpendicular si velocity at si magnetic field. So, ibig sabihin, pwede pong lumiit ang value or ang angle between the velocity and the magnetic field. Na lamang kapag po, diba ito, 90 degrees. Yan, kapag ka-perpendicular silang dalawa. Habang paliit po yung force na yan, paliit ng paliit ang angle, paliit din po ng paliit ang force natin. Until such time na mag-meet ang dalawa, so ibig sabihin, parallel na yung dalawang yan, that is the time na ano mangyayari sa force natin? So, siya ay mag C0. So, yan. So, sabi ko nga, kapag naging parallel na ang direction ng velocity at the magnetic field, there is no force. So, take note ha. So, take note na hindi laging 90 degrees ang or hindi laging 90 degrees apart ang velocity at magnetic field. So, hindi po lagi. So, kagaya nga ng instance na ito, na nag-parallel siya. So, ibig sabihin, hindi po yun or hindi laging 90 degrees apart ang dalawang yun. So, paano naman daw kapag ganito? Beta, velocity. what is the direction of the force? Towards you or away from the monitor. Tama? Tama ba yon? Towards you ba ang naging sagot nyo?
Yes po, sir.
Opo.
Okay. So, if your answer is towards you, then you are wrong. So, pansinin nyo yung mga previous natin na mga given. Anong napapansin nyo? Yung mga previous given natin. Lahat ng given natin from the previous examples are positive charges. So, tingnan nyo yung huling example. So, that is now a negative charge. And if that happens, what you will do now is you will reverse the direction of the force. So, meaning, you will be using your left hand naman. That is the left hand rule. So, kung magnetic field natin is saan? To the right, then ang velocity ko is pababa. Yan. So, meaning, yan. So, magnetic field ko ay pa kanan. Ang velocity ko is pababa. So, the direction of the force is?
Towards the monitor po.
Okay. So, towards the monitor or away from you. If you're going to use your right hand rule naman, so, di ba yun ay to the right, then downward. So, di ba, towards you yan or away from the monitor, all you have to do is to reverse the direction of the force. So, sa halip na towards you, that is away from you or into the monitor. Maliwanag po? Maliwanag po tayo dito? Okay. So, that is how we are going to get the magnitude and direction of our force on a charge. So, gagamitin natin yung formula ng force na F is equal to QVB times sine theta to find the magnitude and the right hand rule naman to find the direction of our force. Okay? So, any questions so far? Nare-recall naman yung mga nang-aral natin? Okay pa tayo doon? Okay po tayo doon?
Opo, sir.
Okay. So, yan. Okay. So, tapos siguro by next meeting na lang kasi sorry talagang masama lang ang aking lalamunan ngayon. Hindi ko alam kung bakit. Siguro dahil last ako ng kahapon ng 7 to 1. Ang dire-diretso talaga as in from 7 to 1. Dire-diretso yun. So, siguro we'll stop muna from here just to to rest for the night. By next meeting, yan. So, mag-discuss ulit tayo since online naman ulit yun. So, we have 2 hours para mag-discuss ulit. Then, siguro by Thursday, mag-ulit tayo ng isang laboratory activity para meron na kayong isang laboratory activity for the semester about magnetism naman yun. Ano? So, any questions so far with respect to our discussion?
None so far po ako, sir.
Wala pa naman po, sir.
Wala pa naman po.
Wala pa naman po, sir.
Okay, so if you have any questions, then just siguro ay ipunin muna. Then by next meeting, we will try to address your questions. Okay? So, if there are no other questions, then that will be all muna for today. Then, see you next meeting. Okay? Thank you.
Thank you
Thank you po,
po.
sir.
Thank you po,
Yes, sir.
sir.
Thank you po, sir.
Okay.